All right, so today we're going to look at some special cases um, and work through a few of these. We've got factoring perfect square trinomials. It ends up being in the form of ax squared plus 2ab plus b squared, and you end up with a plus b times a plus b. So every once in a while when you think like this first example here, says x squared plus 8x plus 16 equals, if you were to factor this, you'd put an x and an x, and then you'd say what times what gives me 16 and adds to give me an 8, and you'd say, oh yeah, 4 and 4. So notice it's a perfect square trinomial because you get 2x plus 4s. That's why it's called that. All right, and then down here, you can do the same thing here. I can um, look at this one here, think what times what gives me 4x squared, 2x and 2x. What times what gives me 9? It'd be a 3 and a 3, and then to get a minus in here, I need a minus and a minus. So if I check my inners here, I get a minus 6x, and I check my outers here, I get a minus 6x, and they do add up to give me a minus 12x. So sometimes you can get lucky here and you can think, oh, square root of 4x squared, that's 2x. What's the square root of 9 there? Oh yeah, that's 3. And then since the middle term here has to be a minus, it'll be a minus and a minus. And that sometimes will work if it's a nice perfect square like that. Same thing up here, we could have done the same thing for the first example there too. You could have thought, what's the square root of x squared? X. What's the square root of 16 there? 4. And then 4 plus 4 gives us me 8. So coming down here, this is factoring the difference of squares. If you can find a nice square root up there of x squared, then you can write the x's over here. If you can find the square root of 16, and the square root of 16 is 4, then because there's a minus here, one has to be a minus and one has to be a plus. So, and that's only true when you have a subtraction sign in between there. So between two terms like that, x minus 4 and x plus 4. So let's go on here and let's look at some of these. Factor each expression here. If you can take the square root of this and of the first term there and the square root of the last term there, let's see if we can do that. Yeah, we can take the square root of this as x. The square root of 9 there is 3. And then 3 plus 3 here gives me 6. But again, you don't have to think of it that way. You can think, what times what gives me x squared? X and x. What times what gives me 9? It adds to give me 6. Oh yeah, 3 and 3. So just two ways of kind of thinking through that, only when that's true, if you can take the square root of the first term and the last term, and then the last term there adds up to be the middle term there. So this one here, if I were to think through this one, the square root of 64x squared there is 8x. The square root of 81 here is 9. And then because I have a plus here but a minus in the middle here, I need a minus and a minus here. And then I just got to check. In here I get a negative 72x. Outside here I get a negative 72x. Do those add to give me a negative 144x? Yes. Again, this doesn't always work. It's only when you can take the square root of the first term and the square root of the last term that it possibly will work. So square root of 36x squared is 6x. The square root of 25 there is 5. And then since we got pluses in both cases here, we need both pluses here. So then let's check our inners here, which is 30x. Check our outers here, which is 30x. Do they add to give you 60x? Yeah, 30x plus 30x does give me 60x. So it's just a special, these are special cases. This doesn't always work, so don't do this every single time. It only, if you could take the square root of that first term and the square root of the last term, and then the terms, the inners and the outers there add up to give you the middle term, that you've done it correctly. You are building a square patio. The area of the patio is 16 square meters minus 72 16 m squared minus 72m plus 81. What is the length of one side of the patio? So a square, if you remember that, is just side times side or length times width, and the length and the width there are the same thing. So we already have this as 16m squared minus 72m plus 81. And we need to get the length and the width. So since it has to be exactly the same here, I'm going to think, what's the square root of this? Oh yeah, 4m. What's the square root of 81? 9. And then what times what gives me a positive but adds to give me a negative here? It has to be a minus and a minus. So then I'm going to check my inners and my outers here. This is negative 36m. This is a negative 36m. Does a negative 36m plus a negative 36m give me a negative 72m? Yes. So my length for, or it says what is the length of one side of the patio? 4m minus 9 is one side length of patio. So special cases. This doesn't always work. Now letter A up there is supposed to factor these. These are back to the difference of squares. So similar to what we've been doing, except you don't have a middle term this time. So looking at this one here, square root of x squared is x. Square root of 100 is 10. One's a plus and one's a minus because that way you don't get a middle term. So if you try to get it inside here, these two would give me a 10x. Outside here, these would give me a negative 10x, and they end up to be 0. So that's what will happen each time. That's why we don't have 3 terms up there. We only have 2 terms. Same thing with letter B here. You can think square root of 25v squared is 5v. Square root of 64 is 8. And then one's a minus and one's a plus. And then letter C there, square root of 36m squared, 6m. Square root of 1, 1. And one's a plus and one's a minus. So it doesn't matter which way you put the plus and the minus. It could be minus plus or plus minus. So it's up to you. So there they are factored. Sometimes you have to pull out GCF out before you can do anything. So let's do just a couple of these. So doing this first one here, what goes into 12 that also goes into 48? Oh, I think 12 does. So I get x squared minus 12 goes into 48 there 4 times. So now I'm looking at what's inside the parentheses there. Oh yeah, that's the difference of squares. Square root of x squared is x. Square root of 4 is 2. And then one's a plus and one's a minus. So if you can find the GCF, pull it out, and then factor what's left over inside the parentheses. Let's go down there to letter C there yet. Looking at 50x squared plus 40x plus 8 and thinking what do they have in common? I'm thinking 2 because I don't think 4, now 4 won't go into 50. So I'm going to pull a 2 out and see if that works. When I do that, I get 25x squared plus 20x plus 4. And again, this is one of those special cases here. So I'm looking for square root. Square root of 25x squared is 5x. Square root of 4 there is 2. And then because the middle here has to be a plus and the outside has to be a plus there, we need a plus and a plus. And then remember, we can check our inners and our outers to make sure we did it correctly. Here is 10x. This is 10x. And they do add to give you 20x. So we're good. It's just 2 times parentheses 5x plus 2 times 5x plus 2. All right. So again, you can pull the GCF out first and then factor it down. So that ends the 4.3e. So you'll be able to work on that 4.3e worksheet here.